All right, guys, this is the second part of 9.1. And it talks a lot about Pythagorean converse and then how to know if an angle is obtuse, acute, or right. So the Pythagorean theorem converse is a thing. And if you remember from chapter 2, that tells us that the converse of this theorem is also true. And the converse is when we flip the hypothesis in the conclusion. So the Pythagorean theorem told us that if we knew that a squared plus b squared, if we knew we had a right angle, then a squared plus b squared equals c squared. Okay, this converse tells us that if we know that a squared plus b squared equals c squared, then we know the triangle is a right triangle. So if we don't know whether a triangle is a right triangle, we can apply the Pythagorean theorem, and if it holds true, then it is a right triangle. If it doesn't, then it's not a right triangle, but we'll go a step further to tell whether that triangle is acute or obtuse. Okay, let's do these two examples first. All right, so if I look on A, it says tell whether the triangle is a right triangle. Okay, now it looks like a right triangle with this is the right angle, but we don't know for sure. Okay, now some of you are saying, well, if we don't know if that's a right triangle, how do we know which one's the hypotenuse? Okay, well, we know the hypotenuse is always the longest side. So if this would be the hypotenuse. And the reason I know that is because I put 3 square root of 34 into my calculator, and I got roughly like 17.5-ish. Okay, so if I just compare these, this would be my hypotenuse. So we're going to pretend like it is my hypotenuse. Okay, so we're going to use the converse of the Pythagorean theorem. So I'm still going to use a squared plus b squared, and I'm going to see if, I'm going to put a question mark, if that equals c squared. Okay, well, a squared, so 9 squared plus 15 squared, and you don't have to, this could be a squared and this could be b squared. These two can be flipped, it doesn't matter. Equals 3 square root of 34 squared. Okay, well, 9 squared is 81, and 15 squared is 225. Does that equal, I still don't know, I'm putting a question mark, 3 square root of 34 squared. Now when I have 3 square root of 34 squared, I have to square both of these parts. I have to distribute this through to the entire parentheses. So this would basically equal 3 squared times square root of 34 squared. Okay, 3 squared is 9. Square root of 34 squared, the square and the square root cancel each other out. So 9 times 34, and 9 times 34 is 306. Okay, so I'm going to put 306 over here. And then I'm going to erase this so we have more room for B. All right, so 81 plus 225 is 306. So 306 equals 306. So in other words, a squared plus b squared does in fact equal c squared, and therefore this is a right triangle. Okay, now I want you to go ahead and do B on your own, and then we'll go over it. All right, now I'm going to set this up the same way. So I'm going to make my biggest side my c, and I'm going to say is a squared plus b squared equals to c squared, and notice that I have this question mark here because I don't know. Okay, well, as I work it out, I get 680 and then 676, which are not equal to each other. And because they're not equal, that tells me it's not a right triangle. All right, so we just learned that if c squared is equal to a squared plus b squared, then we have a right triangle. Okay, but if it's not equal, then c squared has to either be bigger than a squared or b squared, or c squared has to be less than a squared plus b squared. Okay, well, c squared is less than, then we have an acute triangle. Okay, if c squared is greater than, then we have an obtuse triangle. And once again, if it's equal, we have a right triangle. Okay, now before we can do this, we need to know how to check if three side lengths form a triangle. Okay, so I'm going to write here, if the two smaller sides sum to more than the largest side, the three sides form a triangle. Okay, and we'll do an example here in a minute. All right, it says first we want to verify that the segments with 4.3 feet, 5.2, and 6.1 form a triangle. Okay, so we're going to stop right there. So in order to verify it, I want to show that the two smaller sides, right here, add up to more than the bigger side. So I'm going to take the two smaller sides, which is 4.3 and 5.2. Okay, so I'm going to say, is 4.3 plus 5.2, I don't have to square here, is that greater than, and I'm going to put a question mark, 6.1? Because if it is, we have a triangle. If not, we don't. Well, clearly, this is what, 9.5? 9.5 is bigger than 6.1. So I can say, yes, we have a triangle. Okay, so we've verified that this forms a triangle. Now we need to find whether it's acute, right, or obtuse. So the process is the same. Okay, I'm always going to find my c squared, and then I'm going to compare it to my a squared plus b squared. Okay, I'm going to find the symbol that goes here. All right, so my c squared, remember, is always the largest of the three sides. Okay, so in this case, it'd be 6.1. So I'm going to say 6.1 squared. And my a squared plus b squared is 4.3 squared plus 5.2 squared. Okay, so 4.3 squared plus 5.2 squared. I put that in my calculator and I get 45.53. 6.1 squared is 37.21. Okay, so clearly my c squared is less than my a squared plus b squared. Okay, so if we look back here, when my c squared is less than a squared plus b squared, I have an acute triangle. So this triangle here is acute. All right, I want you to go ahead and work through A and B on your own. Use this one here as your example, and then we'll go over it and then we'll be done. All right, so on A, the first thing I want to do is I want to verify that we have a triangle. So I'm going to add the two smaller sides, so 3 and 4, which gives me 7. And 7 is bigger than the third side, which is 6. So yes, I do have a triangle. So now that I know what forms a triangle, I can go to find out if it's acute, obtuse, or right. Okay, so when I do that, I always compare my c squared to my a squared plus b squared. And remember, your c squared is always your largest side. Okay, so I compare 6 squared to 3 squared plus 4 squared. Well, 6 squared is 36. 3 squared plus 4 squared is 25. So my c squared is bigger than a squared plus b squared, and therefore I have an obtuse triangle. And I get that right from here. If it's bigger than, it's obtuse. Okay? And then the last one I want to verify, so are the two smaller sides bigger than the biggest side? 4.9 is larger than 3.5, so yes, I know they form a triangle. Now I want to compare my c squared plus my a squared plus b squared. Once again, my c squared is my largest side, so my c is 3.5. So 3.5 squared is 12.25. And then a squared plus b squared gives me 2.1 squared plus 2.8 squared. And if I put that in my calculator, that is also 12.25. And so because my c squared is equal to a squared plus b squared, I know it has to be a right triangle.